Wow! This is the first time I've seen this kind of small cell called a protozoan with the name Spirostomum. Now, Spirostomum was growing in a little bowl of water that had a piece of tree bark with some lichen growing on it and some moss in the bottom that I got out of the front yard. I took a drop of that water out and I put it on my microscope. And what I saw was a lot of these long, thin guys that could twist and bend in unusual shapes. And if you look at them real close, they got what looks like a round hole in the back. It's not a hole. It's a storage bag of water. Now these guys are called cells. That is one cell that you see on the microscope. A cell is considered the smallest thing that's living. There are some exceptions. And you are made out of trillions of cells. That's more than billions. That's a lot of cells. All different kinds of cells. Well, these cells live all by themselves, swimming in the water looking for food. They actually catch it with a little side part of their body that's got a funnel. And if you bother them, if you touch them, if you bang on the cover slip, which I do in these pictures, you see they contract like crazy. So they got like little muscles inside of them. They aren't actually muscles, they're like the parts or pieces of a muscle. And here are two that came from one. That's right. They can divide in half and make two from one. That's one way that they make more. It's called fission or division, which means dividing in half. And I bumped them. And after I bumped them, they finally did separate here. And then they swam away as two separate cells that once were one. Those guys are twins. They're identical twins. They're exactly the same with all of their information inside of them. The rest of the pictures show close-ups of them swimming by in different colors of light, and some of them get really, really close. You can see their insides. Now remember that little round sac that I told you about that's at the back end? That's the back end's called the posterior end. In this picture it's up on top. It's kind of like away from their mouth. That's where they put all their water. It's like their pee-pee water. They can't help it, but water just keeps coming inside their cells through the outer covering of them. The outer covering is called their membrane, and they can't stop the water from coming in. And when they eat food, they take in a bunch of water. So they constantly are getting too much water. And if they don't get rid of it, they're going to blow up like a balloon and explode. You know, someday I could show you that with blood under the microscope. If we put the blood under the microscope with plain water, it will blow up. So they have to get rid of their water. So this little round sac at the back end, the kind of like the caboose end of the cell, will get bigger and bigger, and then all of a sudden it'll get smaller and water will come out. You can't see the water because the water is clear. But see, right now that little sac is small. But it'll grow larger and larger. And in some of the other pictures, if you watch it, it will squirt water out the back end like a jet engine. See how they're getting bigger already? Now he's got a lot of stuff inside of him. Remember, he's alive, so he's got to have everything he needs to survive. He's got a brain. It could be one of those round things that we see there inside. I'm not sure about that. He has more than one brain. He's got one brain that's big. He uses that to kind of control his everyday jobs, and then he's got some smaller brains, and he uses those smaller brains to reproduce and make more of himself. I can't exactly show you where those are, but you can see that he has little tiny hairs all over him. Those little hairs are called cilia. Cilia, that's what they're called. And they're smaller than the hairs on your head. They're smaller and thinner than a baby's hair on a baby's head, because that hair is really thin. And those little hairs work together, kind of like, I would guess if you had a bunch of kids lined up and you said one kid shake his hand and the next kid's supposed to shake his hand, and they're all connected, and eventually they shake their hands all the way down the line. It would be kind of like a wave traveling down the line if you had everybody in your class lined up like that. That's the way they work. And they can make him move. They make him move either forward or backwards. When he goes forward, he twists. When he goes backward, he twists. And the twisting helps him catch food because he has a groove down the side of him. It's kind of like that funnel I was telling you about earlier. And food gets trapped in that funnel. And once it goes down the bottom of the funnel, it gets pushed right inside his body. It goes inside a little sac, which is like a stomach. That becomes his food vacuum. And he eats it. Sometimes he eats things that are living and moving, and you can see them moving inside of him as he slowly kills them and then eats them. Now you have cells in your own body that have hairs like that on them. Those cells, some of them don't move, like the ones in your lungs, along the tubes where the air goes into your lungs. They're called bronchial tubes. They have hairs lining the tubes. And if little pieces of pollen or dust get into your lungs, especially while you're sleeping, those things will work to push those particles of crud out of your lungs, and they go into your esophagus, into your stomach, and you get rid of them that way. So you have cilia that work inside of you, not to make your cells move, but to make like a liquid that's sitting on top of the cilia move. That liquid is sometimes called saliva, a mucus, not saliva. And it moves and carries crud right out of your body. Here's another big example, a good example of that big bubble of water that's inside of him that keeps getting bigger and bigger, and eventually, remember, it's going to burst by shooting the liquid out the back end. He makes a little hole there, and when he's done shooting it out, the hole closes. Whoop! And you just saw it happen. It doesn't go down to a completely empty ball. It stays there always as a little sac, but the sac gets bigger, it squirts them out, and then it gets small. Now if you look closely at that sac, you can see there are lines on it with little dots. Those little dots are the cilia that are attached, and you can see them on the sides too. They're like little fuzzy hairs. They're all working together. And that's what his brains do. They keep track of the cilia and tell them how to work. It's like electricity. If you took a battery and you connected it, one end of the battery to one side of the microscope slide, and one end of the battery to the other side of the microscope slide, and you touched it to the water that he's swimming in, that electricity would cause him to stop, might cause him to go backwards, and it might even kill him. But it shows you that electricity has a similar effect on how he sends messages to his cilia and gets them to move. Look at how he nicely, slowly spins. Now, do you know why he's going so slow? Because he doesn't go this slow normally. He's in glue. I use a special glue called methyl cellulose, which is the same kind of glue they use to put wallpaper on walls. They use that glue because if you get it wet, it'll come loose and you could take the wallpaper right off. So it mixes with water real good. So he's sitting in water that's mixed with this glue that makes it really thick like cement. So he can't swim fast. And then with a microscope, I can watch him without him moving out of the way and out of the view so quickly. I could watch him forever. And I have watched him for a long, long time. I really like watching these little guys. They're called protozoa, and there are so very many of them. Different kinds, different shapes. They do all kinds of neat different things. Okay, I hope you enjoyed the little protozoa called, I'm just learning his name. Yes, Spirostomum. There are kinds of Spirostomum that get very big. They get so big you could see them with your eye without a microscope. This one is a thin one. He gets pretty long. Maybe if I keep growing them in the water here long enough, they'll get bigger. But there are some that get very, very big that you could even see without a magnifying glass. So maybe sometime when you're outside and you see some water, like a puddle, or maybe some water in a creek or a pond, some rainwater that's in a barrel, or in a little mud puddle, you could take a little bit of that water home with you and look at it under a microscope, and maybe you will find some little tiny protozoa swimming in that water. You didn't even know they were there. Well, have a good day and have fun with science.